مساء الخير. Let us start topic 2 of decision analysis, chapter 13. In this topic, we will explain together how we can calculate the expected value of sample information. In our previous lecture, chapter, topic number 1, we understand how we can calculate the expected value of perfect information, and we identify this perfect information as the information which will transfer the decision maker from being in the risk environmental condition with probabilities to be into a certain environmental condition. Or in another word, the perfect information will give the decision maker complete information about the environmental condition, so one of the environmental condition or one of the state of nature will be assured 100%. This is not practical in practice, because in practice we will be in a certain situation of risk with a certain probabilities, but we can get additional information, and this additional information will transfer us from being on a certain point of risk to be on another point of risk. How? By revising, modifying the probabilities of the state of nature. The additional information which we can get and adjust our probabilities of the state of nature will consider a sample information. So, in our topic, we want to understand how we can calculate the expected value of this sample information. The expected value of sample information is the additional expected profit possible through knowledge of the sample or survey information. A sample or a survey will give us additional information, and this additional information will adjust our probabilities. To go further into this topic, it is essential to get some knowledge about Bayes' theorem and posterior probabilities. So let us first understand what we mean by a theorem, Bayes' theorem, and what we mean by the posterior probabilities, and can we get it? And how we get it? Bayes' theorem and posterior probabilities, knowledge of sample survey information can be used to revise the probability estimate of the state of nature. Prior to obtaining this information, the probability estimate for the state of nature will be called prior probabilities. The additional information, the additional sample information will transfer these prior probabilities to be posterior probabilities. With knowledge of conditional probabilities for the outcomes or indicator of the sample or the survey information, these prior probabilities can be revised by employing a Bayes theorem. The outcome of this analysis are called posterior probabilities or branch probabilities for decision trees. How we can compute these branch probabilities? This require consider our example of Burger Prince with a certain modification. How we can calculate the computing branch probabilities? We can calculate or compute the branch probabilities into several steps. Step number 1, for each state of nature, multiply the probabilities by its conditional probability for the indicator. This will give us the joint probabilities for the state and indicator. Step number 2, sum these joint probabilities over all states of nature. This will give us the marginal probabilities for the indicator. Step number 3, for each state, divide its joint probability by the marginal probability of the indicator. This gives us the posterior probability distribution. Again, computing the branch probabilities can be performed into 3 steps. Step number 1, get the prior probabilities. Multiplying the prior probabilities by the conditional probability of the indicator, the result will be the joint probabilities. The sum of the joint probabilities of all states of nature will give us the marginal probabilities. By dividing the joint probability of each state of nature by the marginal probability of all states of natures, we will get the posterior probability distribution. Let us consider it numerically by our example. Or let us complete our theoretical explanation. The expected value of sample information can be calculated also into 3 steps. Step number 1, determine the optimal decision and its expected return for the possible outcome of the sample using the posterior probability for the state of nature. Step number 2, compute the expected value of these optimal returns. Step number 3, subtract the expected value of the optimal decision obtained without using the sample information. This is what we got in previous example, $14,000 in our example it was. From the amount detailed in step 2, the result will be the expected value of sample information. Efficiency of sample information is the ratio of expected value of sample information to the expected value of perfect information, which we calculated in topic number 1. As the expected value of perfect information provide an upper bound for the expected value of sample information. Efficiency is always a number between 0 and 1. If greater than 0, less than 1. Consider our Burger Prince example with some little modification. Assume in a Burger Prince restaurant, the manager must decide whether or not to purchase a marketing survey from Stanton marketing researcher for $1,000. This means that the Stanton marketing researcher will provide us with a market survey, and this market survey will give us additional information. The contract or the offer is to get this additional information for $1,000. Do we accept or reject? This depends on the expected value of sample information. The result of survey will be favorable or unfavorable. The additional information will add us with information that the economic condition is favorable or that the economic condition is unfavorable. The conditional probabilities related to our state of nature are probability of favorable on condition that 80 customers per hour is our state of nature is equal to 0.2 or 20%. The conditional probability of favorable on condition that 100 customers per hour is our state of nature will be 0.5%, يعني 50%. 0.5, 50%. The probability of favorable on condition that 120 customers per hour, our state of nature, is 0.9 or 90%. Should Burger Prince have the survey performed by Stanton Marketing? From these conditional probabilities, we can deduct another conditional probabilities. Probability of unfavorable condition 80 customer 0.8, because 0.2 plus 0.8 equal 1, because the probability will be favorable or unfavorable. Favorable conditional 80 per customer 0.2, unfavorable 0.8. Probability of unfavorable conditional 100 customer 0.5. 0.5 equal 1. Probability of unfavorable conditional 120 customer 0.1. So we have two types of conditional probabilities. Conditional probability of favorable 80 customer, favorable 100 customer, favorable 120, unfavorable 80 customer, unfavorable 100 customer, unfavorable 120. By these two types of conditional probabilities, and by using the prior probabilities in our example, which we mentioned before in this example in topic number 1, we can get the posterior probabilities as follows. But before this, let us consider the inference diagram. The inference diagram of our problem is as follows. Market survey will affect our restaurant size, will affect our profit. Market survey result. Market survey result. Average number of customer per hour affect the market survey result. And affect the profit also. Posterior probabilities of favorable condition. State of nature 80, 100, 120. Prior probability, which we got in the previous example, 0.4 for 80 customer, 0.2 for 100 customer, 0.4 for 120 customers. The conditional probability of favorable 0.2, 0.5, 0.9. Multiplying the first column by the second column will give us the joint probabilities 0.08, 0.10, 0.36. By getting the sum of all these joint probability, the total is 0.54. By dividing the 0.54 is probability of favorable, the marginal probability of favorable. By dividing the joint probability of each state of nature by 0.54, we will get the posterior probabilities 0.08 divided by 0.54, 0.148. 0.10 divided by 0.54, the result 0.185. 0.36 divided by 0.54, result 0.667. The total of the posterior probabilities must be equal 1. The same procedure, the same table, this table will be repeated for the unfavorable. For the unfavorable, the same state of nature 0.80, 80 customer, 100 customer, 120 customer. Prior probabilities the same 0.4, 0.2, 0.4. Conditional probabilities of unfavorable 0.8, 0.5, 0.1. Multiply the first column by the second column, we will get the joint probabilities 0.32, 0.10, 0.04, but some of them 0.46. 0.46 plus the previous 0.54 is equal to 1, because the previous is the marginal probabilities of favorable, and this is the marginal probability of unfavorable. Dividing the joint probabilities of prior and joint, of conditional and prior, 0.32 by 0.46, the result 0.696. 0.10 divided by 0.46, the result 0.217. 0.04 by 0.46, the result 0.087. This is the posterior probabilities of unfavorable. Also, the sum of these probabilities equal 1. We will use these posterior probabilities of unfavorable and the previous posterior probabilities of favorable in our calculation as follows. Best expected value under favorable result. Under favorable result, the best expected value is the largest expected value of all decision alternatives. Our decision alternative model 1A, model B, model C. The payoff 10,000, 15,000, 14,000, 8,000, 18,000, 12,000, 6,000, 16,000, 21,000 from the previous example. The posterior probabilities of favorable 0.148 for 80 customer, 0.185 for 100 customer, 0.667 for 120 customer. Multiplying 10,000 times 0.148 plus 15,000 times 0.185 plus 14,000 times 0.667. This is the expected value of model A. The expected value of model B. The expected value of model C. Which is the largest? The largest is model C, expected value 17,855. The probability of favorable 0.54. These two figures we have to keep in our mind now. Again, best expected value under unfavorable. We will use the posterior probabilities of unfavorable result. The same. The posterior probability 0.696, 0.217, 0.087 times the payoff. The expected value will be 11,433, 10,554, 9,475. The best 11,433 with probability 0.46. From this figure 11,433 with probability 46 and the previous one 17,855 with probability 54, we can get the expected value, the upper bound of the expected value of sample information. Expected value with sample information 17,855 times 0.54 probability plus 11,433 times 0.46 unfavorable probability. The result is 14,900 $0.88. Without sample information, our best expected value is $14,000. Subtracting this $14,000 from 14,900.88, the result 900.88 represent the expected value of sample information. This is step number 3. As the expected value of the sample information is $900 and Santon marketing researcher his offer $1,000, so we will reject it because we cannot pay for this sample information more than $900.88. By dividing this $900.88 by the $2,000, which represent expected value of perfect information, we explained it in topic number 1. We can get the efficiency of sample information. We can get the efficiency of sample information. Also, this calculation can be performed by an Excel spreadsheet. This is the Excel spreadsheet for favorable and unfavorable, calculating the posterior probabilities. Solution: this is with equation, and this is with solution. Expected value of sample information: if the outcome of the survey is favorable, choose model C. If it is unfavorable, choose model A. The expected value of sample information, $17,855 times 0.54 plus $11,433 times 0.46 minus $14,000 expected value. Expected value without additional information. The result is 900.88. Since this less than the cost of the survey, $1,000, the survey should not be purchased. Efficiency of sample information: we can get it by dividing the $900.88 by the $2,000 expected value of perfect information. The efficiency of sample information is 0.4504, 45%. By this topic, we finish our chapter 3, or what we asked you about for chapter 13. So, thank you. Best wishes for you for the final exam according to the Ministry of Higher Education regulations. Thank you.